Next question. Given function is f of x equal to e to the power box x and then modulus x minus 2 divided by box x plus x when x not equal to 0 and minus 1 when x equal to 0. So options are first option, f of x is continuous at x equal to 0. F of x is continuous at x equal to 0. Option second option, limit extending to 0 positive, that means right hand limit is minus 1. Third one, left hand limit extending to 0 negative, f of x equal to 1, and D option none. So first find the right hand limit, left hand limit of this function. So function is given f of x equal to, okay, so first left hand limit. So limit h tending to 0 negative now. So e to the power box, so e to the power minus h plus modulus of minus h minus 2 divided by box function minus h plus minus h. Clear? So from here, uh, limit h tending to 0 negative, e to the power minus h, what value? This give you minus 1. So e to the power minus 1 and modulus of h is to become h. This is minus 1 and minus h, here minus 2. Okay, now if I put h equal to 0, that becomes e to the power minus 1 minus 2 divided by minus 1. That means I can write 2 minus e to the power minus 1. Okay, this is my left hand limit. Now for right hand limit h tending to 0 positive, e to the power 0 plus h. Okay, so plus modulus of h minus 2 divided by box function of h plus normal h. This is become limit h tending to 0 positive, e to the power h give you 0. Okay, that means e to the power 0 plus mod h, always h, because h is always positive number now. So minus 2 by this is 0 plus h. So from here, e to the power h minus 2 by h, limit h tending to 0, this that become minus 1. Sorry, this does not exist. Sorry, e to the power h minus 2 by this one, so this limit does not exist. Sorry, tending to minus infinity does not exist. So right hand limit, left hand limit, both are different, so this is not continuous at all. So none of these above should be your answer. Now next question. Hmm, 1 minute. Okay, now take another question. This question, try to think, or you have to visualize these questions. Okay, the function is given that f of x equal to 1 when x is rational number. Rational x is rational number, and 0 when x is irrational number. Irrational number. Irrational. And option are, you have to check, verify the function is continuous, discontinuity, whatever. Continuity for all real x. Continuity for all real x. Second option, continuity only at some point. Continuity for some, only at some point. At some point. Third option, discontinuity for all real number. Discontinuity. Sorry. Discontinuity for all real number, for all real. And D option, discontinuity at some point. Discontinuity at some point. At some point. Okay, so how to verify this question? First of all, given that f of x equal to 1 when x is rational number, x is irrational number, you have to check for all real number, because questions are asking for that now only. So continuity for all real x. Assume x naught, take x naught any real number. Okay, assume x naught is any real number. Okay, a real number. First case, case 1, x naught is rational number. Assume, because x naught is any real number now. So case 1, this is the first point, that this is rational number. Sorry, first take x is rational number. Rational number. Okay, so if x naught is rational number, then what about f of x naught? The f of x naught give you one value from here, because when x is rational number, then f of x is 1. That means f of x not equal to 1. Okay, now tell me one thing. I have to take left hand limit, right hand limit, we have to find now. That is the only process. Now tell me one thing. This is my real line. Assume real line. Okay, x naught is any real number. First case, this is rational number. Clear? So I can approaches from left side, I can approaches from right side. Clear? So tell me one thing. There are so many real and there are so many rational and irrational number in left side. Yes or no? Yes, and they are also mixing now. You cannot say that after a rational number there exists irrational number. You cannot say, because all number are real number. So there are so many points which is rational, there are so many points which is irrational. That means whenever you are trying to find left hand limit, first case left hand limit, you can like in this way. Whenever the assume x1 x2, you cannot, I cannot explain in this way. Whenever I am going to left side also, the corresponding functional value, just tell me yes or no, corresponding functional value give you either 0 when x is irrational number. For the case of irrational number, either give you 0 and also give you 1 when x is, this is case of irrational number. Try to understand my point. Rational number, this is all about feelings. Okay, so from left side, whenever you are going to, that means you are passes through every rational and irrational points. Yes or no? Yes. So whenever you are taking rational points, they give you 1. Whenever you are taking irrational points, they give you 0. That means left hand limit also is not a like approaches some fixed point. Okay, they are oscillating between 0 and 1. Same way for the case of right hand limit, this is also oscillating between 0 and 1. Actually the continuous mean what? Whenever your function like this way, whatever. Okay, but they are going to some particular value. Now you know where they are going, means where that function is going. But in that case the function is you don't know where is rational, where is irrational. So the function is looked like whenever taking irrational point, they are going to 0, means still here. Whenever taking next point, assume rational point, assume not next point always rational number, assume they are going 1 here, again back to 0 1 or 0 1. They are not going to particular fixed real number. That is the main means difference between the continuous and discontinuity. So left hand limit and right hand limit also does not exist. Okay, clear? So this is the case 1 when x is rational number. Same way, if you take case 2, x naught is irrational number. Okay, same way you can find a contradiction. That means you cannot approach some fixed point. You are telling that whenever x is irrational, you are going to 0. When is irrational, sorry, rational, then you are going to 1. That means there are oscillating between 0 and 1, not a particular fixed point. So that's why this function never be continuous function at every point, because I take first the case x rational number, next case you have to take irrational points. That means for the both cases you cannot find fixed number. That means both cases the function is discontinuous. And a real number, what about, this is the union of rational and irrational number. That's why the function is discontinuity for all real value of x. This is my answer. Clear? Next question. Given function, this is question number, let me check once, 5 6 question. Sixth question. The given function is f of x equal to x when x is a rational number, x is a rational number, and this is 1 minus x when x is irrational number. Clear? then you have to check the continuity of a point. First, this is if is continuous for all x. Second option, discontinuous discontinuous for all x. And C, this is continuous at x equal to 1 by 2. D, this is discontinuous at x equal to 1 by 2. I have to verify. Okay, so now how to verify that? Let me one thing, that case case 1, assume we want to verify x equal to half. They are asking for half now, so first verify half. For the case of half, so x equal to take 1 by 2, I have to check the continuity of x, x equal to 1 by 2. So limit x tending to 1 by 2 positive. Okay, f of x, I have to find the value of this. Okay, assume f of x taking the value of rational number. Okay, first the case rational number. So what will be there? X tending to, this is the right hand limit, x tending to 1 by 2 positive, and f of x value is what? X. This is give you 1 by 2. Okay, so 1 by 2 give you, if that f of x is equal to, that means irrational. For the case of irrational point now, so I have to take 1 minus x. 1 minus x, just put that value 1 by 2, that means 1 minus 1 by 2, this give you 1 by 2. The So for the both case, rational and irrational, for the both case they gave you 1 by 2 in the right hand limit. That means in the real line, I want to say that this is assume 1 by 2 is here. You are approaching from right hand limit now, sorry, I have to approaches from right side. So whenever you are approaches from right side, you are taking rational point or irrational point, does not matter. Both the case they give you 1 by 2. Yes, in the above problem they give you different value. Clear? What is the difference between in these cases, or in this in two questions? Okay, so now find the left hand limit. Limit x tending to 1, you can go through that h tending to 0, positive, negative, that way also. Okay, here this is does not matter, that's why I am taking only. So f of x, so whenever the function taking rational or rational point, they give you x value, that means x tending to 1 by 2. Okay, let me try in the age tending to 0 way, because otherwise maybe some students have confusion. Okay, so left hand case, age tending to 0 negative. Yes, so I have to change x by 0 minus age. For the positive, 0 plus age. Okay, I think clear. Is tending to 0 minus, so x value, since f of x functional value is x, then you have to write 0 minus h. Okay, so these that give you 0 value. Yes, and the limit h tending to, sorry, not 0, this is 1 by 2. 1 by 2, sorry, this is my mistake. Sorry for that. Sorry, 1 by 2, because sorry, this is my mistake now. So x tending to a, that becomes h tending to 0 when x a plus h or a minus h. This is the case only now. This is my mistake, sorry. uh, okay, now next, h tending to 0 minus when f of x is irrational point, then limit h tending to 0, in place of x you have to write half minus h. That means 1 minus of 1 by 2 minus h. Okay, that becomes also 1 by 2. So right hand limit equal to left hand limit equal to, for the both cases this become 1 by 2. And also the corresponding functional value, what? If x is rational, this give you also half. When x belongs to rational number, it is belong to 1 by 2 also, when x belongs to irrational also. That means this is also equal to f of 1 by 2. Clear? So the function is continuous at x equal to 1 by 2. Okay, now we proved that x equal to 1 by 2, the function is continuous. Now we have to check for another point. Now, otherwise, I am directly C option, then I approaches that way. Also, I have to verify that other options are wrong or right or wrong. Okay, so take any another point. Okay, your choice. Assume any random point. X node is another point. which is not 1 by 2. Clear? So I have to check that the function is continuous or not at this point. Okay, now limit x tending to x naught f of x. This give you limit x tending to x naught f of x value when f of x is like x na. Okay, so that means when x is rational number, I don't want to write, try to understand. When x is rational number, then the corresponding functional value is x. That becomes then x naught. Yes. So first I want to I want to say that x naught is not equal to half. We already assume. Yes. So whenever the function value is irrational type, means function taking irrational points, then 1 minus x. Okay. So that becomes 1 minus x naught. Okay. So if the function is continuous, then obviously these two values should be equal. Yes or no? If not equal, then why they are not? The why means you can say that this is continuous function. Obviously, so you assume na this function is continuous. That's why x not equal to 1 minus x naught. Yes, na. If I again I am repeating this thing. If the function is continuous, then these two values should be equal. Yes. If not continuous, then obviously they are not equal. But we assume that this is equal. Find the value of x naught. This is 1. 2x not equal to 1. X not equal to 1 by 2. Array, we already says that this is not equal to half. Again, this is came 1 by 2. So that's why except x not equal to 1 by 2, another point should be discontinuity point of that function. Okay, that's why the C option is correct option. Clear? And another way you can verify that whenever this type of question came, just try to equal them. X equal to 1 minus x. Find the value of x equal to 1 by 2. This is the actual point where the function have continuity or discontinuity point. Okay, clear? So using in this method, you can easily say that at that point maybe the function is continuous or discontinuous. Okay, otherwise every point may be discontinuity or continuity. So I think clear. Okay, done.